Okay, moving on to some more things about exponents and radicals. So what is a radical? A radical is some stuff underneath one of these square root bars. Okay, so the thing under the bar is called the radicand. Radicand. Okay, and then I said square root bar. That's a little misleading. This is because this thing doesn't have a number here. You assume it's 2. Okay, that's the indexed, right? But it could be something else. It could be a number, right? And this is called the index, kind of like the power, but with the radical, this is the index. And that could be anything. Okay, so all radicands greater than or equal to 0 have square roots, positive. It could be positive or negative. Okay, this is called the principal square root. Okay, so if this is a 0, if this isn't listed, okay, it's assumed to be a 2. Okay, if it's assumed to be a 2, if it's not listed, otherwise, it is whatever it is there. Okay, so because things can be squared, right? Anything squared, let's just talk about for squared things here. Okay, anything squared becomes positive. Okay, so this is saying what multiplied by itself would be x. So let's take for the example, square root of 25. Okay, so this is saying what times itself equals 25, because this is a 2. All right, so what times itself equals 25? Well, that would be, obviously 5 times itself equals 25, but also -5 times itself equals 25, because negative times a negative equals a positive, right? So if we go -5 squared is 25. So the answer to this, right, this actually has 2 answers, right? It could be, we could actually have, negative, well, it could be, so 5 times 5 equals 25, or 5 times -5 equals 25. Okay, however, right, the square root of -25 cannot be a thing, right? Nothing times itself equals -25, right? Until we get into complex numbers. You can't multiply. See, I can't multiply anything by itself. I have to have one thing times another thing. These are not the same numbers, right? One's the opposite, or not quite the opposite. One's the negative of the other. That equals -25, right? These are multiplying the same things by each other. Either way, I get a -25. Now, if I put the third root, I guess this would be 125, right? If I put the third root of it, right, -5 times -5 times -5, that's possible. I can have a negative sign underneath a cubed root, right? So like if I do 5 negative times 5 negative, that's the square root times 5 negative. Well, that's 125, right? So that can be true, right? But if this is ever positive, I'm not going to have a negative underneath here. Okay. A positive root is called the principal square root. So a positive root is principal square root. Positive square root, principal root. is the positive square root. Square root is the positive square root, and it is always positive. Always positive. But anytime you have a positive root, it'll always be a positive number under here. If it's a negative number, it's not possible, right? So if I have let's see, 972 or 5 negative, and let's see, where's my cube root? There it is. And I take it to the 6th, it gives me an error, right? If I do 872 to the negative 84th, it gives me an error, right? As long as that is a positive number as my index, it will give me is an error, right? If it's positive and my radicand is negative. Okay, the only way I have a negative sign under my radical and it is positive and it is negative is if this index is negative. Okay, so unless we have a complex number, an imaginary number, which we're not getting into until much later in the course. All right, so let's talk about breaking down radicals and simplifying radicals. Okay, so say we have a radical. All right, let's do something pretty easy first. Let's do the square root of, let's pick something. Let's do 248. I just made that up. Let's see if we can figure something out here. So we got to factor this. Let's break this down into smaller components. Let's see if I pick something that's easy to break down. Okay, I picked a nice even number because it's kind of easy to break this down. Well, let's do 248 and let's divide that. See if it breaks down into 4. Okay, that's useful. So 248 divided by 4 is 62. Okay, so we have a 62 and a 4. Okay, why did I pick 4? Okay, well I picked 4 because 4 is a perfect root. Okay, it's a square root. I can take this 4, and if I take it out of the radical, it turns into a 2. Okay, so now I have 2 square root of 62. Okay, now does the 62 break down into anything? Okay, well the 62, let's divide that by 2. It's 31. Well, 31 is a prime number. Okay, I can't divide 31 by anything to make it smaller. Okay, so I can't break this down anymore. I'm not going to be able to find, I can't do 62 divided by 3. Nope. 62 divided by 4, 62 divided by 5, nope. 62 divided by 6, nope. 7, nope. No, 60. So that's going to be my final thing. Okay, let's try another one that may be a little bit more complicated. Let's do the square root of, we'll say, let's do, I don't know, 100 and, I'm going to pause it and think of something good. Let's do 192. 192. All right, let's start with my normal go-to process. This is just my process. If you want to do a different one, break it down a different way, go for it. But I like to do 4 because it's the easiest, 2 and 2, right? So if 192 divided by 4, hey, it worked. So I have 192. Oops, so that's not right. I have 148. 192 is the same as 48 times 4. Okay, so let's bring that 4 out as a 2, and that leaves me with, let me move on over here, that leaves me with 2 square root of 48. Well, does 48 break down into anything? Well, 6 times 8 is 48, so let's do 6 times 8. Now that doesn't break down anything else, but how about 6 times 2 times 4? Okay, well there's another 4. Alright, so 6 times 2 times 4, I can bring that out. Right, so that's going to be 2 times 2, right, so that's going to be 2 times 2 is 4, and I have 6 times 2. Well, it's going to be 3 times 2 times 2. Well, I know that 2 times 2 is 4, right, so I'm just going to bring that out as another 2. Okay, so I can do 2 times 2 is 8 times the square root of 3. Okay, so I can check my work now. So 2, or 8 times the square root of 3 equals 3 square root times 8 equals 13.856 something. And if I do the 192 square root, it's the same thing. Okay, so this is this simplified in radical form. This is the most precise number that you can get. If I put this into a calculator and I round it, this is not as precise. If I just typed in like 13.8, what was it? 192 square root, 13.9-ish, 13 point, if I rounded it, this is not nearly as precise as 3 square root times 8, right? Not nearly as precise. And if you write it like this, you'll see in the future that algebraically this is easier to work with than using rounded decimals. Okay, so that is working with radicals. All right, now if you think about this, say for instance we were working with this part and this was part of an equation and we had like an 8 square root of 3 and another like say plus 4 square root of 3, you can act like this square root of 3 is just like an x, right? And you can add like terms. Okay, this would be like 12 square root of 3. Okay, that's why using the square root of 3, a square root of 3 is useful in algebra. Okay, so let's move on to some more stuff. So let's talk about cubed roots here. So let's say we have a cubed root. We have a cubed root of negative 27. All right, well, let's break down 27, negative 27 into something. All right, so what's 27? What do I need to get 27? Well, let's do 27 is not a prime number. Well, 27 divided by 3 is 9. Okay, so I got negative 3 times 9 is 27. What happens if I do, well, 9 is negative 3 times negative times 3 times 3. Okay, but I have to have the same thing, I have to bring out the same thing 3 times, right? I have like 2 of one thing and then 3 of the other. But if I multiply, what happens if I multiply, what do I need to multiply to get 9? Right? I need to multiply 3 times 3 to get 9, but I can also multiply negative 3 times negative 3 to get 9. So I can turn these into negative 3 and negative 3. Okay, so that works. I can do negative 3 times negative 3 times negative 3. Now I have 3 negative 3's. I can pull that out. Now the whole answer to this is just negative 3. Okay, so let's look at a cubed root a little bit more complicated. So let's say we have the square root of negative 256. Well, let's start first by dissecting 256. All right, so again, I like to start with 4. Okay, let's do the square root of, cubed root, the cubed root of 200. I know I can do this because this is an odd number. So 256, let's divide that by 4. We have 64. Okay, so we have negative 64, and then we have 4. Okay, so that's how I get that. Maybe I have negative 4 and 64, but I'm not really gonna. I don't have a cube root for 4. I can't do anything with 4. So let's look at 64. What do I need to multiply 3 times to get 64? Well, let's see. 4 times 4 is 16. How about 2? About 2 times 2 times 2 is 8. That doesn't work. 3 times 3 times 3 is 27. That doesn't work. 4 times 4 times 4 is, hey, that's 64. Right, so if I multiply 4, and 4, that's 64. It's not negative 64. Right, but if I made these negative, right, 4, negative 64, that would be what I need to do. Right, so I need to bring negative 4 out of this. I can bring negative 4 out of here. Right, negative 4 times the square root of 4 is the same thing as the square root of negative 265. Right, so just utilizing a little process of elimination and subtract and dissecting the number, you can eventually get to your correct answer. Okay.